Hello everyone, welcome back again to my channel. My name is Oluwaseun. Now, last week we talked about Jenkins deploying to ECS and other things. And also, I published an article last week on GitOps to help us understand the GitOps practice and how it's going to be the future of DevOps practices. Now, in today's video, we want to go into the hands-on of GitOps. We want to see how we can, use GitOps. We want to understand the concept better from the angle of an hands-on practice. But before we delve into the hands-on, now, for those who perhaps have read the article and they are still trying to understand, what GitOps really is, trying to still, piece together the concept of GitOps. Now, today, I want to just quickly, maybe within 5 minutes, give us an understanding of what the GitOps concept is about. Now, the GitOps concept is something that was coined at Weaveworks in 2017. And basically, the idea is that since we are already using Git as the repository for application code, and sometimes we also even store our Terraform template, CloudFormation template, even Kubernetes manifest files, Docker Compose files, all those things are checked into the GitHub repository. Now, the idea behind GitOps is that since we check all of these files into the Git repository, can we just make Git as the single source of truth for all of these applications? Now, what does that mean when you say Git is the single source of truth? Now, what it means basically is that take an example of your CI/CD pipeline. Let's say you're using Jenkins, for example. Now, the Git repository is connected to your Jenkins pipeline. And there's what you call a webhook, meaning when you push into the GitHub repository, Git in itself is able to trigger your Jenkins pipeline to start the build based on a push event that has occurred in that repository. Which means when somebody pushes into the repository, based on the trigger configuration that you've configured, Git is able to trigger Jenkins to say, hey, something has changed in this repository. I think you need to build, the pipeline and, check what has changed, right? And then your Jenkins pipeline builds and then it gives you whatever result, right, that you desire. Now, the same thing happens when you're using GitHub Actions or GitLab CI/CD. Your code is already checked into the repository. So anytime you push into that repository, the repository knows that something has changed because now it has a new commit ID. So based on that new commit ID, it definitely knows that there's time to what? To deploy something new. There's time to change something in your CI/CD environment. So the people at Weaveworks talked about it and says, since Git is already a version control system and Git repositories, they have, administrative controls where you can set, the person that can approve a push request or a merge request, all of those kind of controls are already there. Why not make Git as the single source of truth? So in a work environment, what you now have is basically that you have your Terraform script in a repository, you have your Kubernetes manifest file in another repository, and then you have your application code in another repository, right? Because what you can do with Git actually is that you can use Git to also deploy your infrastructure. So if I want to create something on AWS, maybe I want to create some infrastructure on AWS, I don't have to do it locally. I can also create my infrastructure through the pipeline. Right? Because if I go through the pipeline, then somebody has to check, somebody has to approve, and then within the CI/CD pipeline, I can even integrate certain security checks to check my Terraform's code if it conforms to standards and to be sure that, we're not just defining it, for example, security group, all the port numbers are well defined and all of that. Right? So we can deploy that through the GitLab CI/CD or through any CI/CD pipeline. So with GitOps, you can also deploy infrastructure with GitOps. Now you can also deploy your infrastructure, your application code with GitHub as well. So are you pushing your application code into your Git repository, your Jenkins pipeline, GitLab CI/CD, GitHub Action is triggered automatically. Now another thing that they now deal with GitOps, the concept is that now with a Kubernetes environment, the DevOps practice, there were a lot of still some minor processes with DevOps, right? So what they did with GitOps is to say that, Now that we want to make Git as the single source of truth, what are the tools that we can create that can also connect with Git that can help us to deploy to Kubernetes directly without going through any kind of manual process, without triggering the pipeline manually and all of that, right? Now, that is where you now have tools like Argo CD and Flux CD, right? Because with Argo CD, with Flux CD, what you also do is also that you connect your Argo CD or your Flux CD with your Git repository, and then you configure what you call a webhook or a trigger and all of that. Now, the moment your Kubernetes manifest file changes inside of your Git repository, your Argo CD is also triggered automatically, and then it deploys to your Kubernetes cluster. And one of the things that has made GitOps so easy is the fact that all of the files that we're dealing with, your infrastructure files, your Kubernetes files, quite a number of these files, even your pipeline script, right, is written in mostly YAML. Or even if it's not YAML, it follows the declarative language, which means you only have to tell the pipeline, you only have to tell Terraform what to do, and then it figures out how to do it. Okay, so that is one of the things that has made even GitOps even become more popular, and then of course everybody is adopting it because the Kubernetes file is declarative, your Terraform script is declarative, your pipeline script, whether it is GitLab or GitOps, Actions or Jenkins, it's all declarative. All right, and then you commit that into your pipeline, the pipeline is triggered. So what you now have with GitOps is that your Git is actually the desired state for your infrastructure, for your application code, and then for your Kubernetes environment. So whatever it is that you have in your Git repository is regarded as the desired state, that this is what I want to have. Now, your environment, on the other hand, is what is called the actual state. So with GitOps, what you now have is you have your desired, and then you have the actual state. So if the actual state has deviated from the desired state, then all of these tools that are built on the GitOps concept will do what you call a reconciliation. For example, your Argo CD is deployed inside of your Kubernetes cluster. So it monitors the Kubernetes cluster and all of that. And then, of course, there's one leg inside of the Git repository. So if you push something into your Git repository, Argo CD looks at it and says, okay, this is now the new desired state, but the actual state in the Kubernetes environment does not match the desired state that you have in your Git repository. So what does Argo CD do? It basically just go out of sync, and then it reconciles the desired state with the actual state, making sure that what you have in your Git as the desired is also the same thing that you have running in your environment. Right? So that is basically what GitOps is about. So there's the desired and there's the actual. So your Git repository represents the desired state of your infrastructure, your application code, your Kubernetes environment, and then the environment itself, whether it's your Kubernetes environment, your infrastructure on AWS, is actually the actual state. So these tools that are built on GitOps basically have one leg in the Git repository and then another leg, all right, in the environment, basically to help you reconcile both environment to be sure that what you have in your Git repository is also what you have in your environment. Okay, but the principle remains that Git is now the single source of truth. So whether you want to deploy to your environment and create some infrastructure with Terraform, your code is checked into Git repository. Whether you want to deploy to Kubernetes environment, Git repository is where your code is checked into. Okay, and then you have tools that are now built on this concept to help you actualize and make use of this concept in a more efficient, manner. Now, I believe that with these few explanations that I've given, I believe now you understand exactly what GitOps is about. And so let's get into the hands-on and let's see how we can use the principles of GitOps, to deploy our infrastructure and to also deploy our application code. So let's get right into the answer. So now here, I have two scripts that I have created. So one is to deploy the application, right? I mean, we want to deploy a simple Hello World application that is written in Python. So this is the simple Hello World application written in Python that we want to deploy. And then we have a Docker file right here. So this application that we want to deploy. And right here also we have a GitLab CI, which is our pipeline script. Okay, I'm going to walk you through what we have in the pipeline. Now, apart from that, also, I have my infrastructure here because I want to deploy my infrastructure with the CICD as well. Okay, I want to create my EC2 instance, create some roles, my infrastructure basically, my VPC, NAT gateways, all of that. Okay, so I have my Terraform script here. Now, for those of us who do not know what Terraform basically is an infrastructure as code that can allow you to define your infrastructure in the form of code. Okay, so which means instead of going to the console to create your resources, you can basically just define your infrastructure as code, and then you can deploy it more like you're running a normal application. But in this case, it has its own language. In the case of Terraform, it follows, well, let's say it follows the Java kind of, approach because of the curly braces and all, right? But of course, it's still a declarative language, which means you don't have to explicitly tell Terraform how to do what you expect it to do. All you need to do is to tell it what you want it to do. And then Terraform figures out the how. Okay, so that is basically what Terraform is. So I'm going to be going through these things, all right. I'm going to do a little rundown for us to understand what we have here. So two things that we want to do: we want to deploy our infrastructure with GitOps, and we're also going to be deploying our application still using the same principle of GitOps, right? Because the idea actually is that all of these applications that we have defined here, this infrastructure we've defined here, everything is going to be checked into the Git repository. And then, of course, our Git repository already has a CI/CD component that we're going to use to deploy the application and the infrastructure. But of course, the first thing we need to do is to deploy the infrastructure, and then we now deploy the application on the infrastructure that we have created. Is that okay? So now we're dealing with AWS, and then we have the provider here as AWS. Okay, so for those of us who are not familiar with Terraform, maybe we're going to do maybe a beginner class on Terraform, but of course, pardon me, okay, just follow whatever it is that I'm doing, because I mean, GitOps itself, it's an advanced kind of concept, okay, but I just thought to share the thoughts with us today so that we can see exactly what GitOps is about and how it is used in a normal production environment. All right. So here you have the provider. So we're dealing with AWS. I want to deploy my infrastructure to AWS, and so you have the provider here, and then you can see here that I have quite a number of Terraform files. So there's the data.tf, locals, main, providers, Terraform TFs, and variables. Now, if I click on providers, here I already defined the provider that I'm using. So the provider is Terraform. So the provider is AWS. Now, one thing here is that I'm defining a backend, which basically is to store my Terraform state file. Because with Terraform, you have what you call the state file. All right, you have the state file. Now, the state file is basically more like Terraform's inventory that defines all of the infrastructure that you have deployed in your environment. Right, so it's more like an inventory for Terraform to keep track of the infrastructure that you have in your environment. So anytime you apply Terraform, anytime you create any resource with Terraform, it basically updates the state file. So if you delete your resources as well, it basically also updates, all right, the state file. So what we're doing here is we're using the S3 bucket as the backend so that the state file is going to be stored into the S3 bucket, not within our CI/CD pipeline. Because if you store your state in the CI/CD pipeline, don't forget the CI/CD pipeline, particularly with GitLab, runs with Docker, which means for every job you run, a new container is created, right? And then for that new container that is created, your state file may not be available in that new container. And then when you want to delete your resources, you may not be able to delete it again because it can't find the state file. All right. So we're using S3 as the backend so that the state file is not kept within the pipeline, but rather it is external. So that in case you want to update or you have colleagues that are working together with you on that same project, okay, you can basically reference the same state file and get an update of what is going on in your environment. All right, so that's what we're using S3 as the backend. And of course, right here, I've created a bucket. So this is the bucket that I've created on AWS. Okay, and then of course the key is basically infra. This will be like a folder that will be created, and then my state file will be stored. And the region where my bucket is also defined right here as EUS2. Okay, and then here I'm specifying an HashiCorp AWS provider because I'm deploying to AWS, all right, cloud. Now here I have data. So data is basically a way to fetch values from your cloud provider, right? There are values that I need from AWS. So the only way to get that is to fetch it. So using the data block. Okay, so if you hover your mouse over here, it tells you a data block requests that Terraform read from a given data source and export the results under the given local name. Okay, so that's what Terraform expects. So it reads from a given data source. which means Terraform is going to authenticate with your AWS environment and then read from that environment and get some results, okay, that you can reference as an input for the resource block. Is that okay? So that is exactly what we're doing here. So we're saying depends on module VPC because we're going to be creating our VPC using the Terraform VPC module. All right. And then here also we're using the security group. We already have security group for the VPC. So we're referencing that. And then for the data block as well, you can also filter, okay, based on certain parameters. So if you're looking for certain things, you can also use the filter keyword to filter for certain informations. All right, just something to match, okay, with what you're looking for. Okay, and then we have all of this data. Now, one thing we want to do here is this. We want to create two instances. Now, one instance is going to be for a GitLab runner, and then the other instance is going to be for the application server. Now, we want to create a GitLab runner because our application code, we want to use our own runner to run the pipeline, right? We don't want to use the shared runner, okay, from GitLab, that GitLab makes available for us. We want to basically use our own runner. Now, another thing that we also want to do here that we have added in this project is that now, by default, you already know that if you want to access your instance on AWS, you access your instance using SSH. That's like the popular approach, right? But here, we do not want to access our instance with SSH. We want to access our instance with SSM, all right? Which means we don't want to use any SSH key at all. We don't want to create any key pair. We want to basically access our instance using SSM, which is at least one of the security best practice on how to access your instances because you don't need a key pair. All right. So now, in order for us to use SSM, we have to create what you call a role. That instance that we want to create is going to assume. All right. By now, I expect that you know what a role is. And if you don't know what a role is, I have a video on that. I'll put the playlist in the description of this video. Now, we want to create a role. Now, that role is going to contain different policies. One of the policy the role is going to assume is the SSM parameter role. And then, of course, we also want to be able to connect to ECR because the application code that we want to use, we're going to be building Docker image from that application code. And that means we have to connect to ECR to be able to push to ECR. So another thing we want to do also is that we do not want to add code credentials really, right? By the time we're deploying our application, we want to basically just use the GitLab Runner, which has now assumed the role for SSM, for ECR, and all of that. So inside this Terraform script, we are using what? Some kind of data to fetch some informations, right? Now, if you come here to the main, all right, section, and you come here, you're going to see some kind of data that we using here. Now here we have data, which is to fetch something, okay, and an IAM policy, and then the policy that we are fetching is this particular policy. Now this is a policy that is a managed policy on AWS, right? You can get it on AWS documentation. You can go to your console to go and also get it. I mean, if I come here now and I open my IAM section, for example, all right, if I go to policy, okay, I can come here now. The policy name is what? Is SSM Manage Instance Call, right? So I can come and say SSM, all right, Manage Instance Call. So I can expand this and then I can see it right here. So basically, if I copy this ARN right here, the ARN that you see here is basically what I've copied and then I have put right here. So basically, I am referencing this particular policy because I want to attach it to a row. Right? So now another policy here is the ECR, registry full access. Okay. So I'm also getting the ARN as well. And then I'm also getting the ASM full access ARN also. Now right here, I'm now creating a role. Now this role is going to also have what you call the STS assume role, right? And I want to allow this role to be able to interact with EC2 service. Okay, because there are different principals that you can have on AWS, right? You can have a service as a principal. You can even have AWS account as a principal. You can have a user as a principal as well. But in this case, we are dealing with EC2 because we want to be able to use this role, attach it to an EC2 instance, and then allow that EC2 instance to be able to communicate or interact with other AWS services. So we need to create what we call, all right, a role. Okay. All right, so now that role is coming here, and then we're doing some policy attachment as well. So right here, I'm also creating a resource called policy attachment. Now, all of these things are things that when you go to the Terraform documentation, you can actually get it from the Terraform documentation. Okay, and then the role here is basically this role that I've created right here. So AWS underscore IAM underscore role dot app server role. And that is what I'm referencing right here. And then of course, I'm also referencing the policy that this role is going to assume. And that policy, you can see that we're using a data block, right? And that policy is the one that we defined right here. Okay, and then we are basically referencing the ARN. ARN here means Amazon Resource Name. Okay, it's basically the name that you give to a particular resource on AWS. In most cases, these names are actually auto-generated. Okay, they are more like an ID that you can use to reference a particular resource on AWS. So anyway you see ARN, it basically means Amazon Resource Name. Okay, so I'm creating all of that and then I'm defining all of these things. Okay, now I have another role for the GitLab Runner. Remember, I told us that we're creating two instances. So one for the application server and then one for the GitLab Runner. All right. Now for the GitLab Runner, we're also creating, all right, a role as well. So IAM role, and that is the name of the role. And then here, assume rule. So it's going to assume, it's more like a trust kind of policy, trust relationship, right? That this particular role is able to interact with EC2 instances on our behalf, right? So if I attach this role to an EC2 instance, that EC2 instance automatically has the privilege based on the policies that I'm referencing to talk to or to interact with other services on AWS. Is that okay? All right. Now, so I'm doing basically the same thing. So I'm basically attaching. I mean, these are things that you would normally do on the console. When you create a role, you have to attach the role, all right, to a policy and all of that. So that's basically what we're doing right here. Okay, and then here I'm creating a VPC using the AWS Terraform module for VPC, right? And then I'm defining my CIDR, private subnet, AZs. Now, all of these ones can be managed using variables and all of that. But for now, let's just add code them right here. Okay. And then here, I'm also querying I'm also creating my availability zones, right? So I have data.aws availability zones.name, right? So I'm basically querying the availability zone based on my region. Okay, my region is already defined. If you come here to variables, I already defined the region as EUS2, right? So right here, what I'm basically doing is that I'm querying that region, okay, for the number of zones that are there. And then right here, I'm saying enable NAT gateway is going to be a single NAT gateway, and I don't want one NAT gateway per AZ, just one NAT gateway for all the AZs. It's okay. And right here, I'm also configuring some environment variable, right? So Terraform basically means it's true. So it basically will mean that if this resource is created now, it basically will have a tag to say that this resource was created with what? With Terraform. And then I have an environment variable called dev, which I have right here. Okay, dev. Okay. All right, and then here also I'm creating a security group. Now we're creating a security group ourselves. So we have the ingress, which basically is to allow any traffic from within the VPC CIDR. Okay, if you look at the VPC CIDR is 1010/16. So we are basically allowing traffic just within, all right, the CIDR. And then we have the egress the egress doesn't really matter, in most cases. So we have the egress as, allowed from anywhere. And then here we have another security group, particularly now for the application server. Now, the application server would allow, all right, ingress, from any ports, okay, but within the VPC, which means the GitLab runner and the app server, they should be able to talk to themselves without any kind of restriction. Okay, so that's why we are restricting the traffic to the VPCs within, through the CIDR block of the VPC rather. And then you have the ingress here. Now, the application we are deploying is going to be a Python application. So it's opened up on 8080. So we have here to say that 8080 from and to, which means, the source basically, all right, should be from anywhere. Okay. But then the traffic, the protocol is TCP, and then of course the port is port 8080. So which means allow from port 80 and then to port 80. Okay, that's what we have. And then of course, as usual, the egress, it's almost like the same. Now we have another module here that we're using, which is the AWS EC2 module for Terraform. And then right here, we're basically defining the name, the instance type, the availability zone. So we're using elements to read, all right, the availability zone. So this 0 basically means the first element in this list should be picked. And that will usually be the first zone, right? So that will be like, EUS1A. Okay, so that will usually be the first zone. So element basically means the first element, okay, in that list. So element retrieves a single element, all right, from the list. So, and then that single element we're using this 0 to basically mean the first, all right, in that list. So that'll be EU West 1A. Okay. And then for the AMI, we're also using the data to query. Now, if you look at the data block, we already defined some data that, Terraform can query. And so we're referencing all of that right here to make things easy for us. Now, the IAM instance profile is basically when you create an EC2 instance, you can go to the security, all right, tab and then modify an IAM role. Okay. And that's exactly what we're doing here. So basically we're saying that once this instance is created, it should assume this particular role that we have created already within our Terraform configuration. And then, of course, it should have VPC, public IP address, and then the security group, all right, is the security group that we created, okay, right here. This one right here is the security group that is going to be assuming. And then the subnet ID is also going to be, all right, the subnet that we defined right here. So this one, so we're using the public subnet right here. So that's the one we're defining, okay? And then we also have, so I think that's all. And then we have the user data. Okay, so we have two user datas. Now, one is for the application server and one is for the GitLab Runner. Is that okay? And then we have the tags right here. And then we have the Terraform basically saying this is created with Terraform. The name of the server is app server. Then we are defining the volume as well. We're using GP2. The volume size is 8. The delete on termination is also true. All right. And then for the GitLab Runner also, we're using the same AWS EC2 module. And then basically the same thing, but just, the same operating system, but different security groups and different IAM role is what we're going to attach, all right, to them. And that's basically all. Now, if you look at this user data, we are saying base64 encode, and then we're using local.script-gitlab. Now, if you expand this particular folder, I have two scripts. Now, one is for the GitLab Runner, which basically will install the GitLab Runner on that EC2 instance and configure the runner, all right, as well with some, necessary installation. So, for example, we're using Ubuntu AMI. That means we have to do apt update, and then this is the URL to basically install the GitLab Runner. And then we have sudo apt install. We're also installing Docker as well because we want to use Docker executor for the GitLab Runner. We don't want to use shell executor. We want to use Docker executor instead. Okay. So now we have all of that. And then we have here, we're installing Docker. And then here, we're also adding the Docker, the Ubuntu user to the Docker group. And we're also adding the GitLab Runner to the Docker group as well. So that from the CI/CD pipeline, we should be able to run Docker, commands and all of that. Right. And then here we're also installing AWS CLI as well. And then right here, we're configuring the GitLab Run. So we're doing some registration. Now, this is something that after you've installed your instance, you'll have to log in into the instance and then do it manually. But we want to do all of that using a script and then, of course, through the CI/CD pipeline. So we have all of these runner. We're registering the runner, the token, the registration token, which we're going to generate shortly. And then the executor is going to be Docker. And then the Docker image that our executor should use is going to be Docker 27.3.1. And then in addition to that, we also want to change a configuration file for the runner. Okay, and that is all of these things that we have right here. These are just shell scripts and jargon. And then, of course, we have the SED command, which is basically to substitute something. Okay, so it's going to read the file and then substitute the values that we have here, all right, for what is available there. And then it's going to write that file back. Okay, again. And then now we're doing Docker restart and then GitLab Runner restart as well. All right. So we're doing all of these things using the CI/CD pipeline and all. So for the other one, we'll basically just install Docker because on the app server, we want to run a Docker container on the app server. So that means the app server should have Docker installed, right? So that's what we have right here. Okay, so we're installing Docker. This is more like what we have done already with shell scripting, but now we're bringing that into the CI/CD pipeline. So you can see that all of these things, whatever knowledge that you have, whether you have the knowledge of shell scripting, at some point this knowledge becomes valuable, right? You can see here that this is not a shell script, but it's a template file, but the syntax is still the shell scripting syntax. Okay. So if you have the knowledge of shell scripting already, you can easily understand what is here. Okay, so that is basically what we're doing. So the variables are here. We're defining all the variables. So this runner registration token, we need to generate a registration token that we're also going to put into the pipeline configuration as well. So we can go ahead and do that. So I'm going to come here. I think I have a tab opened up. So I'm going to come right here. So these are my repository. I've not pushed anything here yet. So I'm going to come to settings and I'm going to click on CICD. And if you go to variable, I already have some variables here like access KID, secret KID, the region. But I'm going to come here to runners and I'm going to say, all right, new runner. So I'm going to click on new runner. And then I'm just going to call this runner. So let's call this GitLab. Okay, I mean, just a tag. And then I'm going to say create runner. So it's going to give me the steps and then the code that I need to register the runner. So I'm going to copy that, right? I'm going to copy that and then I'm going to come here. So I've registered the runner. I want to leave this page as is so that by the time the runner is registered, you're going to see right here. So I'm going to come right here. All right, I'm going to come here. So I'm opening it in another tab and I'm going to go to CICD again. I'm going to click on variable and then I'm going to add a variable and I'm going to call this, all right, runner underscore token. And I'm going to put that value right here, and then I'm going to add the variable. Okay. Now the variable for the runner token has been added, but of course we also have to add it inside of the Terraform script as well. Okay, we need to add it there. So I'm going to come here to my GitLab, so I can see that I have my runner underscore token here. But I'm going to come here to my Terraform TFS. Now, don't worry about my access key and secret key. I'm going to delete that right after this video, so you don't have to worry about it. So I'm going to replace the runner configuration, the token, with a new one. And that's all I have to do. So now, if I look at my pipeline script, I have my init, test, plan, apply, and destroy stages, right? And right here, I'm using the HashiCorp Terraform image, the Docker image, okay? And the entry point, basically, I'm overwriting the entry point, which means allow me to execute my own commands. That's what this means, okay? Because if you don't override the entry point, there are certain commands that are already there that will execute by default. But we do not want that. We want to execute our own commands. So we have the entry point, and then we're saying, just allow us to run our own commands. Now, these variables, we're basically exporting this variable inside of the CI/CD, the access key, the secret key, and the region. All right, we're basically making that available because this Terraform TFVAS, actually, we're not going to be checking it in to the repository because these are sensitive data. Okay, but if I wanted to run this locally, then of course I need my Terraform TFVAS. But since I'm running it through a CI/CD pipeline, I do not need a Terraform TFVAS. Okay, and that is why I have put everything inside of this particular variable. So the runner token, the secret key, the region, and then the access key, everything is already here in my CI/CD variable section of the pipeline. Okay. So I don't need the Terraform TFVAS because, if you look at my git ignore, I've actually excluded the TFVAS. So it's not going to be checked into the repository. But of course, I just updated it for updating its sake. All right. Now, if you go back to main or if you come back to my pipeline configuration, so the variables here, there are 3 of them. So the access key, secret key, and the default region, I'm basically referencing them inside of the pipeline to make their values available for Terraform to be able to use. Because these variables, AWS underscore access underscore key underscore ID, they are standard variable. So even if I don't use TF underscore var, right, Terraform is able to pick them up automatically and make use of their values because they are standard what? They are standard, all right, variable that you have there. So now I have my init, which basically will do my Terraform init. And then if you look at it here, I also have an artifact. Now the artifact is basically to help me to, make available the .terraform folder and then the Terraform log file for other jobs. Now in the GitLab series that I did, which I'm going to link in this video, there is what you call the artifact and there's what you call the cache. Okay. Now the cache is basically useful for dependencies. When you want to make dependencies available for other jobs, you can use a cache for that. But when you want to make a particular artifact, right? For example, when you do Terraform init, it's going to create a .terraform folder and then a Terraform.log folder, right? Now, these folders are needed all right, by subsequent, Terraform commands, like your Terraform plan, your Terraform apply. They need this .terraform folder and the Terraform.log file in order for them to really operate. So what are we going to do? Instead of using a cat, because this is actually not really a dependency, so we can use an artifact to basically archive those particular folder and then make it available for subsequent stages in the pipeline. All right, so that's why we have the artifact here and then the path. So the path basically, it just says, this is the file that I want to save. So what Terraform would do is that after the Terraform init, it's going to look for a .terraform folder and then a .terraform.log file. It's going to look for them after the init, and it's basically just going to make it, all right, it's going to more like archive it, all right, and then make it available for other jobs within your pipeline. Okay, and then we have the Terraform validate, which is basically going to validate the syntax and the semantics of the Terraform configuration. And then we have the Terraform plan. Now, since we're running it in a pipeline, we don't, it's not interactive, so we cannot say yes, no, and all of that. So we have to create what we call a Terraform plan. So the Terraform plan is going to be outputted out as a file called plain file. Now, that plain file also have to be, we have to produce an artifact for that as well, so that the Terraform apply can basically use that, okay, to create all the resources that we want Terraform to create. Is that okay? So we have that deploy, and then of course we have the Terraform destroy, which is basically going to delete everything. Now you can see that for the Terraform deploy and the Terraform destroy, I basically have the keyword when, which basically means manual, which means I want to trigger this particular jobs manually. I'm not going to trigger them automatically. I want to trigger it what? Manually. Is that okay? So now we have the CI/CD configuration. We're going to push this into the Git repository, and of course, we are going to see the GitOps principle in action. Okay? All right, so let's go through all these things once again. So variable, we have all the variables here. The Terraform.tfs, like I said, we're not checking it into the repository, so we really don't need it. The providers, we have a backend as S3. The main.tf, we have the creation for EC2 instances, the GitLab Runner, the application server as well. And then we have the locals, which is basically what we're using to reference the scripts. Okay, so the reason why we're using locals here is because we do not want to repeat, right, this particular configuration multiple times. So we're creating a local here. So the local here is script and then the template file and all of that. So what we just have done is to go back to main, and then right here in the user data, we're just basically referencing that. So local.script-gitlab. Okay, that's what we're referencing. So local for the other one here, we reference local.script, okay, and it's basically going to get the value and do the job all right for us. Okay, we already passed in the script here. We're passing the other one here as well, so it's going to just do the job. And then in order for us to deploy our application to the instance, we also need to output the instance ID. Because like I told us, we're not going to be accessing that instance with SSH. Rather, we're going to be accessing the instance with SSM parameter. So the instance ID is important for us to have so that we can get the instance ID and then put it into the application CICD, and then with SSM we can deploy our Docker image on that particular instance. So here we are doing module because we're using an EC2 module. So module, the name of the module that we're giving it, and then the ID of that instance. So it's going to generate the ID of the instance for us as an output, and then we can just copy that and then use that in our pipeline. So that is what we have here, right here. So I'm going to push this to my Git repository now and then see what is going to happen with these setup. So let's go ahead and let's take a look at this. So now I'm going to say git add, and then I'm going to say git commit -m, and then we can say GitOps infra. Okay, these are our infrastructure. And then I'm going to say git push. It's a new repository, so I've not pushed to it before. So I've a new origin, and then the origin is GitOps infra. Okay. All right, so that should push into the repository now, and of course the pipeline should be triggered automatically. So let's take a look at the pipeline. So I'm going to come back right here, and then I'm going to come to build, and then I'm going to click on pipeline. All right, so we can see that the pipeline has been triggered. So let's take a look at what we have. Okay, so the GitHub init actually failed. So let's take a look at what happened. Why did it fail? So let's see what happened right here. Okay, All right, so it says validating provider credential, retrieving call identity from STS operation, get call identity, decomposing, blah, 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 invalid header value. So basically, it's an authorization issue. Okay, that's the issue that we have. So it's an authorization issue. So it says invalid header, field value for authorization. Okay, and that was around Terraform init, models, AWS VPC. So let's troubleshoot this and let's see what the challenge is. Why did it fail? So providers, let's take a look at that. Okay, the GitLab Terraform init. All right. So after several attempts to resolve that error that we were having, which is this one here, right, it was giving us this error. So I've been able to resolve it. And what I did was to come here to settings to CICD. And I went to variables. And of course, I had to change the variable from, because I was using protected and expanded. So I had to use maxed and hidden. I guess that was what I did and it worked. So if you look at it here, basically I checked this maxed and hidden and then protect variable and expand variable. And that is basically all I had to do. Okay, and now it worked. So we have, you can see that different attempt that I tried, it just failed. So, but now we have a successful initialization. So if you click on this init, you would realize that now S3 has been initialized as the backend. You can see that here. And of course, it says Terraform has been successfully initialized as well. And because we use the artifact keyword, you can see also that it was able to upload some artifacts, about 284 of them. And you can see from here that those artifacts can actually be downloaded if you want to. All right. So now this artifact will be useful for other jobs. So, and that's exactly what we would do. So I'm just going to go back to the pipeline and click right here. And then we can run the other test. So I'm going to validate. Okay, that should not take too much time anyways. So I'm going to validate, and then after the validation, then we can do the planning. So validation is just to check your Terraform configuration, if it conforms to the syntax, structure and semantics and all of that. That's what validate is about. And then we will have the plan. The plan will now, generate an output for us as to the things that we want to create. And then we'll deploy the infrastructure. So let's take a look at the validate and let's see what that is giving us. So it tells us here that, success, the configuration is valid. So we don't have any issues with that. So I can come here and then click on plan, which is the next phase. And then I can click here, and of course I have to manually run that as well, because that was what I configured, that the job should be triggered manually. So let's take a look at the logs together for the plan. Let's see what we have for that. So of course, if you look at what we have here, you can see that we are actually using the shared runner. So we're not using our own runner, but of course, what we are trying to do now is to create our own runner with the necessary configuration, like I showed us in that shell script. All right, so the Terraform plan is now running. So let's take a look at that. So you can see that it's doing some reading using the data block. So it's reading some stuff. And right here, it tells us that about 35 will be added. So if we decide to go with this plan, 35 resources will be created for us. And of course, we're going to be outputting out the ID, the instance ID of the app server, because we're going to need it for the other job as well. All right, so now the plan has also succeeded. Okay, and then you can see that it also generated an artifact, okay, which is the plan file that the Terraform apply is going to leverage to create the resources for us. So I can come here also and go to apply. Okay, and of course, we're going to trigger that as well manually. Okay, because in a work environment, these are things that will have to go through different approvals for your job to be applied. You can't just go ahead and push into your CI/CD pipeline and then you're applying something. Somebody has to check that you're doing the correct thing. That is why you have the when manual, because as far as that person has checked and the person approves, then the pipeline can be triggered after the approval. Okay, to be sure that you're deploying what is right, so that you're not just deploying what you feel you should deploy. So there are different levels of approvals that we're going to get. So you can see right here that the Terraform is creating the resources. You can see all the resources being created, the instance profile and everything. So everything has been created, the route table, the VPC. So I'm going to pause my screen here and then I'll come back when this whole thing is completed. There you go. So you can see now that the resources have been created. So now we have all the 35 resources added. And of course, we can see the app server. We can see the ID right here. So even if you don't go to the console, we can get the ID from here and then we can just grab the ID, right? And of course, the runner should be registered. I mean, anytime from now, we can come back here and take a look at the instances, right? So we can come here. This is the repo. So we can click on the EC2 instance right here, all right, and then go to instances. And we can see the two instances, right? You can see that the two of them is initializing at the moment. So it's going to take a while because if you come back here to your runner, you can see that the runner is not registered yet, because if it's registered, then we should see, you've registered the runner kind of information. Okay. So we can see now that the instances have been created. And of course, if you click on the instance and you come to security, you can see that the role has been attached, and of course the inbound role was configured as appropriate. And then if I click on the app server and I go to security as well, I can see that the role was also attached, right? And then I can see the security group that we configured as well. Okay, so everything has been automated. Okay, so now the only thing we need to just wait for is the instance, the status check to be 2/2 or 3/3. And then we should also wait to see that the runner has been registered successfully, because now instead of us doing this manually, we've automated that process as well using the CI/CD pipeline and the GitOps concept. So we can wait a bit. And of course, if you come back to your bucket and you refresh as well, you should see that you have the infra folder created and then the state.tf file. So you can see that your state file has been created as well. So you can see the size also. Okay, so let's wait for the instance to complete and then we'll come back when that is done. So we can see now that the instances is now 3/3, so which means both instances are running. So that means if I come here to my register, you can see now it says you've registered a new runner. So you can see that the process was automated. We didn't have to do anything manually. Everything was done through the CI/CD pipeline. So the runner is installed, is ready. The app server is also ready. Now, another thing that you can do in order to test the SSM configuration that we've done is that you can click on your runner or on any of the servers and then click on connect, and then you can come here to session manager and then you can say connect. And if the role was configured correctly, we should see a terminal session right here. So you can see we have a terminal session right here. So now if I do sudo system CTL and I say status GitLab Runner, I can see that my runner is active. Now, I didn't need any SSH key for this, right? And then, of course, I can check my Docker configuration as well, right? I can say sudo system CTL status Docker as well. I can also see that my Docker has been installed and is running as expected, right? So that tells me that everything is configured properly. And one beautiful thing about the SSM configuration is that if you go to Systems Manager, all right, if you go to Systems Manager, you'll be able to see the two servers that have been registered, right, with the Systems Manager right here. So if you come here and click on Fleet Manager, all right, you would see the two instances right here. So you can see these are the two instances. So the app server, the GitLab runner. So both of them are managed, in a way by the systems manager. Okay, so you don't need any SSH key to basically log into these instances. All right, so that is done. So we can come back now. The runner is registered. We can click on View Runners. And that would basically tell us that the runner is now online. All right, so we can see that the runner is online and the tag is GitLab. So let's take note of that. So for the next job, we're going to use our own runner. We don't want to use the shared runner. We're going to use our own runner. Now, that also means that we need to do a little thing, right? Now, when we deployed the infrastructure, right, the EC2 instances and everything, we needed the access key and the secret key. But now our job is going to run on our own runner, and that runner has SSM, all right, has a role attached to it. And that role, if you come back here to the instance, right, let me close this. If you come back to the instance and you click on your GitLab Runner, and then you come to security, it has this role attached. And if I click on that role, I can see that that role has a few permissions, right? Number one, it has the permission to connect to ECR, and then it also has SSM full permissions. And then if I click on the trust relationship, I can see that it also has the STS assume rule. So if you look at the trusted entity, we can see that we have the principal, the service is EC2. So this rule, if we attach it to our EC2 instance, it basically means that the EC2 instance has the permission to do these two things: connect to ECR and then SSM, all right, connection. So these two things are the things that our EC2 instance can do, all right? So now what we want to do now basically is to go to the pipeline for the application. Since our GitLab runner has SSM access and ECR access by the virtue of the role attached to it, it therefore means we don't need the access key and secret key again for the application deployment, because the runner itself is where the job is going to run, and it already has this role assumed. So we don't need any access key, we don't need a secret key anymore, right? So, and that's exactly what we want to do. So the next thing we need to do now is to go back to that code. So I'm going to come here and I'm going to come right here. Okay, so this is the application, right? The GitOps application, the application that we want to deploy. So we're going to build and then deploy. Now here I have a variable called image name. So this image name basically represents the ECR repository. All right, and then I have the account ID, and then I have the default region. So one more thing that we need to quickly add is the account ID. So if I come back here to CICD, I can come to variable, and then here I will say add variable, and I can come to my environment here, and then this is my account ID. I can grab that and basically just put that here. So I can say AWS account ID. So let's see that AWS. Let me grab that from here. AWS account ID. So I'm going to copy that, and then I'm going to put that here, and then the value. Okay, oops, sorry. So I need to copy that again. So here, copy your account ID, the CICD settings, put that here, and then you add the variable. So the account ID has also been added. So now we have the account ID, and then this basically just represents the full path or the full URL of your ECR repository. Because if you come here to your Elastic Container Registry, this is the URI. Okay, so this is your account ID. All right, and then this is the DKR, blah, blah, blah. And then here is your region, the EU West region. And then here, right here, it's your, repository. And that's exactly what we have. So the account ID, the DKR, the region, and then all the other values. All right. So the first stage is to build. So this is the Docker file. So we want to build, a simple Docker file to just say hello world. So it's a build, and then we're using the build X. To do the build, right? And then of course, because we want to build and push at the same time, it means that we have to authenticate with ECR, right? And so if you look at the image that we're using here, we're using the Docker image, okay? And then we're saying app no catch add AWS CLI, because you need AWS CLI to run AWS CLI commands. Okay, so here we are adding the AWS CLI into this particular image, because this Docker image doesn't come pre-installed with the AWS CLI, all right, command. So we need to install that. And then we're using the app, which is the package manager for the Alpine Linux. And then no catch basically means, just for this particular session. So it's going to add that. And then now we're saying AWS ECR get login, more like you do your Docker login. Okay, Docker login, then the region. So the default region is still there in the variable section of the CICD. Docker login, the username is AWS, and then the password is going to be passed in as a standard input, basically to not make it visible in the log. And of course, in this case, we're not even using a password, right? It's going to get a token from ECR that it's going to use for the authentication. And don't forget, our GitLab runner, which this job is going to be running on, already has a role connected to it that gives it full access to ECR. So that means the runner is able to get the token to authenticate with ECR and then push our image to ECR. All right. So that's what we have right here. And so once we have authenticated, then the script will now be docker build X. We're using build X. I build and then -t. So we're going to be producing two images, one with the commit SHA of the repo. All right. And then the one with the latest. And of course, we're doing push also at the same time. So we are building and pushing, all right, at the same time. So once you build, just push immediately. We don't need to create any kind of section for the push job, all right? And then, of course, we're deploying. Now, the deploy part is where we're going to be using some SSM parameter commands, okay? Because like I told us, we're not using SSH. Okay, we're basically connecting to the instance with SSM. All right. So if you look at these SSM parameters now, we're using the image we're using here is the Amazon AWS CLI image, and of course we have the entry point. Okay, overwritten as well because we want to execute our own commands. Okay, so we want to execute our own commands. So we have the AWS CLI, and the script here is login. All right, I mean, we have all of these things because now you want to deploy to your EC2 instance with SSM. Now, the same way, if you're using SSH, you still have to authenticate with your ECR to fetch your image from ECR. Okay, so in this case also we want to do the same thing, all right, at the same time. Okay, so we have the login command, we have the command to execute, and then we have the command ID. So the login command, which is login CMD, is basically, all right, executing the authentication with the ECR, because the ECR is a private repository, it's not a public repo, which means everything that we have there, you have to authenticate in order to fetch something from the ECR. Okay, so if you look at what you have here, you have the ECR, get login, and then of course you're authenticating with ECR to be able to fetch your image, and then commands to execute is docker run -d, all right, -p. We're familiar with all of these commands, and then we have this image column latest, which is basically the image that we want to pull from ECR, all right, and then here you now have the command ID, which is the SSM command itself. Okay, so you now have all of that. Now, all of these things, I'm sure you're wondering, I mean, where did we get all these things from? So if you come here to AWS, all right, SSM CLI commands, let's take a look at that. So if you come here and you click here, you are going to see, I mean, a few commands that you can use with your SSM. So right here, this is the AWS command line reference where you can get, I mean, any command for AWS CLI. So if you look at this place, it has different available commands. So here, if you look at some of the ones that we used in the pipeline, all right, we have the SM get command invocation and all of that. So if you scroll down, okay, let's see. So we can see the get document, all right, that's one of the commands that I think we referenced somewhere here, all right, the document name, you can see that, and then we can see some parameters right here, and then some commands and some queries. I don't just want to bore you with all of this, right? But then if you come here, you can see all of the parameters. I mean, you can see get document, you can see get parameter, all right, you can see that we use something parameter here as well, right? Parameters, you can see that, okay? And then because what we used here is SSM, AWS SSM send command, right? So that means if I scroll all the way down, I can see send command. So if I click here, now this send command will also have some sub commands, all right, and some options. I mean, if you understand Linux a bit, you will know that every command in Linux has what you call options, which means the command can be used as a standalone command, or depending on what you want to do, you can pass in other arguments or options that allow you to even expand the usage of that command. Is that okay? So the same thing also happens here. So the send command has options, as argument that you can use to expand the use of the command. Okay, so for example, now we have the document name, which is one of the argument. You have the target, you have the, all right, you have the target, you have the document hash, you have the parameter right here, and then of course the value. Okay, I mean, you have a whole lot of stuff right here, because if you look at what we have AWS SSM send command, instance ID, basically to say that this is the ID that we're dealing with. We have the document name, all right, which is basically what you want to do. You want to run a script, all right, on that particular instance, and then you have the parameter. So the parameter is basically a combination of the commands that you want to execute, all right, in your with SSM. Okay, so the parameter flag also has this argument that you can pass in. So if you come here, it says parameter and then value. Now, the beautiful thing about all of this, I mean, you can see all the options, instance ID, you can see that. So if you scroll down right here, you're going to see a lot of examples, right? If you scroll down, you're going to see some examples here. So let's scroll down and let's see if we can get an example. All right, let's see global options. This is also there. So you can see some examples here. So AWS SSM send command, document name. So the document name by default comes with this AWS run shell script. That's more like the default value. And then you can see the parameters. So this is how to use the parameters. So commands, and then the things that you want to execute. You have the targets. The target here basically can mean the EC2 instance where you want to target, or any kind of environment you want to target. And then you have the comment in case you want to pass a comment. And it is going to be like the output that you will see, all right, after you've done all of this. And then here's another example that you can use as well. So you can see here that the command is basically different from SSH, because if it were to be SSH, you just reference the SSH key and then do some SSH commands, like maybe some shell commands and all of that. But right here, we are using SSM. Okay, and then after we are done, we're going to also use, this is send command, and then you also have the SM get command, and then get command invocation. So this get command invocation is what will now basically, deploy whatever it is you want to deploy to your instance ID. And then of course, it's going to also invoke this particular command ID, okay, to do the job. So that is basically what SSM will do for us. So you can see that it's a bit different, but I'm sure when you go through the documentation here, and that is why it is always good to go through documentations as well. Okay, so they can understand the options and how to use a particular command. Is that okay? So what we need to change here basically is just the instance ID, and I think we're good. So I'm going to come back here, and then I'm going to just copy the instance ID, and that is why we had to output that right here. So I'm going to come back here and then just replace that. So my instance ID, I'm going to replace that with this one, and then I'm going to replace it right here, all right, as well. Okay, I mean, it's just as simple as that. So now the next thing I need to do is to also push this to the repository, and then just see the job execute, right? So let's push this to the repo and let's see what we have this time around. Now, but before we push into the repo, like I told us, we need to delete the access key and the secret key, because now we're using our own runner. So we don't need the access key again and the secret key, because our runner already has a role connected to it that would allow it to talk to the different AWS services that we want to talk to. So I'm going to come right here and come to settings, CICD. All right. And of course, I'm going to go to variables, and my access key ID, I'm going to delete that. My secret key as well, I'm going to remove that also. Okay. So I don't need all of that again. So the runner token is not needed again, but we can still leave that. But we still need the region, and we need the account ID. So we're going to leave those two as is. Now, I think that's all that we need to do here. Okay, I think that's all that we need to do. I don't think there's any other thing else that we need to do. Let's just check again to be sure that we don't need to do anything again. All right. So now we can do git add and git push. So I can say git add and then git commit -m. So we're going to call that git, let's call it GitOps app, and then git push -u origin, and then the origin is GitOps app, right? So that's the origin we want to push to. Okay, so now if I go back to my pipeline and I come to here to build and I click on pipeline, I should see that the pipeline has been triggered. All right, so now there's going to be an issue. Okay, so you can see that it says it's stuck, right? Because if you come to the settings and the CI/CD settings, so if you come to runner, the runner label that we're using is GitLab, not Docker. Okay, we didn't remember how to change that. So the runner we want to use is GitLab, so we didn't remember how to change that. So I have to come here and then change the tag to GitLab, not Docker. Okay, so that's the tag of the runner we want to use, the GitLab. Okay, so that's why the pipeline got stuck. And then I'll just say git commit -am. Okay, runner tag changed. Okay, so let's push again. So that's going to basically create a new pipeline. So we can come here to build pipeline. And of course, we can see that the new pipeline has started actually. All right, so you can see that this one got cancelled. Okay, and then we can come back here to see what is going on. So this is building the image. So if I click on this one, we can see right here, it says IP address is this, which is 10.0.101.178, and we can see 333, and we can see the image that it is using. So that means if I come here to my environment and I look at the instance, all right, and I go to DDoS, and I look at here, I see 10.0.101.178, right? So that basically tells me that this is using, all right, it's using, so let's look at that again. So 101.170, so it's using my my runner. But we have an error there. So let's take a look at the error. So error response from daemon, okay, blah, 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 look up, let's come no such host. All right, so let's take a look at what the error is. So we're saying ECR get login, all right, the default region, the login password, all right, so the default region is EUS2, okay, and then it's telling us that no such host. All right, so get HTTP, something is missing here, right? So the account ID is kind of missing. So let's take a look at what we have to be sure that we are configuring correctly. Okay, so the account AWS account underscore ID. All right, so let's check the pipeline and let's see what we have in the CI/CD settings. Okay, because I mean, something might change. So let's take a look. So AWS underscore account underscore ID. That is exactly what we have. AWS underscore account underscore ID. So that's what we have. So why is it not picking that up? Okay, so why is it not picking that up? So that means we've also run into another error. I mean, you remember the last time we ran into that error and then we had to just look at what the problem was. So we're also faced with the same thing now. So let's take a look at that. So the only challenge I see here is that the account ID is actually what is missing. So that's why it's telling us it can't find that. All right, so the region, I mean, it's picking up the region automatically, but it's not picking up the account ID. It's not picking that up. So that's where the issue is. So let's go back to settings and then let's just quickly look at that. So CI/CD variable. So what's the difference between the region and this? So this one is protected, expanded, but I'm not sure all of these things really mean much, but let's, I mean, for the benefit of doubt, let's uncheck the expanded and let's just say save changes, right? So let's see if that would, I mean, would basically change anything, right? Oh, okay, so expanded is what we want to look at, right? So let's say expanded and not protect. Okay, save changes. So now it is expanded. Okay, so let's see if that would change anything really. All right, so all you can do is you can go back to the pipeline and just, I mean, you can rerun the pipeline again. I mean, if nothing changed in the code, you can basically just run the pipeline, you know, like that. And you can see now that it's using our own runner, using Docker executor, and then using the image that we specified in the pipeline. So that's what it's using. So let's wait and see what this is going to give to us right now. So it shouldn't take too much time, right? Because what we want to build is not even as heavy as that. It's just a simple Docker file. So it shouldn't take much time at all. So but let's wait and see. So you can see now that this is done. And basically just a little tweak in the variable section, I mean, solved that for us. And we can see that the thing built. So if you scroll up, all right, you can see the old build. So you can see it's connected to the ECR. The login was successful. Okay, and then the image was built and then pushed, okay, at the same time as well to the ECR. So that means if I come back here to my Elastic Container Registry and I refresh this, and then I click on my GitOps one here, I can see the image, and then I can see the latest, and then I can see the one that was also with the CI, the commit hash of my pipeline. I can see all of that. And then, of course, scanning was also done automatically. And then I can see that that image has about 69, high kind of severity, okay, 218 medium. Of course, we're not going to get into that. So, but of course, you can see the statistics here, and that tells you that this image is not secure enough, but we can leave that for another day. All right. So now that we have done all of these, we can actually just go back to the pipeline and then deploy with SSM. So I'm going to just go to deploy. All right, and then I'm going to deploy the test. So since my image has been built, I can go ahead now and deploy to my SSM, to my environment with SSM. Okay. So what I need to do here is to just say run the job. I mean, it's a manual trigger. So now this is going to run the SSM commands for me, and then it's going to deploy my application to my EC2, all right, environment. Okay. So let's see what that would do. So we're using another image now. I mean, that's the importance of using a Docker executor, because you have the privilege to use different Docker images for different, jobs that you want to run within your pipeline. So let's take a look at this. So the login command for SSM parameter is already running already. So we can see that in action through the pipeline. And of course, it's still running through GitLab Runner. You can see the IP right here. So we're not using a shared drive. So it's running through that. And then, of course, the SSM command is being all right. So the job actually succeeded. Okay, you can see that the job succeeded, the pipeline passed, and there's no issue whatsoever. Okay, so the pipeline has passed. So now if I click on pipeline, I can see that my pipeline actually passed, this time around. So the build image and the deploy image, all right, passed this time around. So now I can actually come here to my instance. And since I deployed to the app server with SSM, I can click on the app server, click on connect, and then of course I can also use session manager to connect. So connect to that. I don't need SSH key. And I can just basically log into that app server and then verify my deployment. So I can come here to say, let me use sudo, okay, sudo docker ps. And then right here, I can see that my image was deployed, my hello world image was deployed. So that means if I come back to the instance and I grab the public IP, and I put it right here and I say colon 8080, I should see my hello world application right now. Guys, can you see that? So the principle of GitOps is to basically say that everything emanates from your Git repository. Okay, so Git is serving as a single source of truth. All right, so you push into the Git repo, whether you want to deploy your infrastructure, your application, to Kubernetes, to any environment, you're basically leveraging Git for every of your operations. Is that okay? So as you can see now, we've done everything. So the application was deployed with Git. The infrastructure was also deployed using the CICD pipeline, right? And that is basically the concept of GitOps. So one more thing that we need to do before you go is that we need to delete our environment. I mean, that is very, very important, right? So we need to delete the environment. So I'm going to come back to my pipeline. So I'm going to come back to my CICD section, and then I'm going to go to variables, and I'm going to add back my access key and secret key so that I can trigger the Terraform destroy that will destroy the environment, all right, automatically. So I'm going to come here to add variable. This time around, I mean, let's just do what we have to do so that we don't keep going back and forth. So my secret key ID, I think I can get that from here. Let me see. Let me see here. So don't worry about the key. I'm going to delete it after the session. So I'm going to come here, put the value here, and then I'm going to say add variable, right? And then I'm going to do the other one. So that is going to be for, all right, the secret key now. So the secret key, we need to grab that as well. All right, and then I'm going to put that here, and then I'm going to say add the variable. So this time around, what I'm going to do now is that I'm going to, So the secret key that it didn't add correctly, because now it can be telling us some kind of grammar and all that. So let's save the changes. It won't allow us. So let's copy the key. Let's delete that. All right, and then let's add it again. So make sure you select the correct thing. The secret key, paste that here, make sure everything is well selected, add the variable, so that we don't run into the error we ran into the last time. So I'm going to come back to the GitOps project, and this is my branch, the infrastructure branch, right? So I'm going to go back to the pipeline. Remember, we manually triggered the build. So the destroy one now, I'm going to manually trigger that. And remember, my state file is actually in S3. So it's going to take a look at that and use that to know what is available and what should be destroyed. Because I want to destroy everything. I don't want to go to the console to do anything manually. So let's just destroy it also through the pipeline. And that's exactly what I'm doing. So it's going to leverage the state file that I already have in S3. And that is why we had to create the S3 backend as well, so that, you can leverage that to basically know what we have and then use that to do, the destruction of the whole infrastructure, so that we don't have to go and delete the instances manually, the NAT gateways, a lot of things that was created. All right, so with the state file now, it can actually read the state file, know what we have, and then help us with the deletion, very quickly. So you can see that this one is using the shared runner. So it's going to take a little time to run, because this is a shared runner. So it's going to take a little while to run. So let's wait for that to happen. Let's see what we have with Terraform destroy. All right, so you can see that now it says plan to add 0, but of course 35 to destroy. So it's going to destroy all the 35 resources that we have created. So, and of course, it has started destroying. As we can see, it has started destroying. So, it's just so easy because I didn't have to go to the only thing I had to do on the console was just to create my ECR repository, which can also be added to the Terraform configuration as well. So really, you don't have to go to the console to do anything, because in our own environment and where I work, we don't really do things on the console, right? Everything is just through the pipeline, through GitOps concept and things like that. So thank you so much